When we're describing transformations to graphs, the first thing that we may want to note is that it doesn't matter what kind of specific equation we're talking about, whether it's something that's squared or something that we're taking the square root of or absolute value. The effects of these variables, these numbers, will be the same no matter what kind of function we're dealing with. So take a look at everything in the top row. Everything in the top row deals with numbers being added or subtracted to our parent functions. Those will have the effect of translating or sliding our graphs. And specifically what we're looking for is whether or not that number is being added or subtracted inside the parentheses or the absolute value bars or underneath the radical, or whether it's being added or subtracted outside of those things. So if you're being added or subtracted inside, this is a horizontal shift. So I'm going to go ahead and label that as such. So it's a horizontal shift or a horizontal translation of the graph. And the horizontal shift always does the opposite of what it looks like it's going to do. So if I'm seeing adding 9, I would normally think of moving to the right. This is actually backwards of what it will do. And so this will actually be a horizontal shift left 9 spaces. The horizontal shift always does the opposite of what it says. If the number's being added outside of the parentheses or the absolute value bars or whatever, it's going to be a vertical shift. So this will actually shift the graph up or down. And if it's added outside like this one, the vertical shift always does what it says it's supposed to do. So this will shift the graph up 9 spaces. Every single point on that graph will be shifted up 9 spaces. Next up, we have 2 of them. There's one. Notice it's underneath the radical, so that'll affect the x. It'll be a horizontal shift, and it does the opposite of what it says. So once again, this will be a shift to the left. Specifically, it's going to be shifted left 3 spaces. And then finally, this number here at the end is outside of the radical, so that will be our vertical shift. And it does what it says it's going to do, so that will shift the graph down 2 spaces, my vertical shift. Okay? If you look at the bottom row here, these all involve multipliers. Multipliers are going to be stretches or compressions. It'll either stretch the graph vertically or compress it horizontally and so on. So the first thing is we want to figure out, depending on where that number is located, whether it's a vertical or horizontal motion. Well, once again, if it's outside of the bars or the parentheses or whatever, this will be vertical. And the vertical always does what it says it's going to do. So that 4 is going to multiply everything, so the graph is going to be stretched 4 times as tall as the normal graph would be. So I'm going to say that this is a vertical stretch, and then more specifically, this is a vertical stretch by a factor of 4. All right, so I'll just make a note of that, by a factor of 4, by a factor of 4. So the graph is going to be 4 times as tall as the original. And then lastly on this screen, I've got a very similar looking equation, a very similar function. But notice this number this time is inside of the absolute value bars or parentheses or whatever. This will always be horizontal if it's grouped in there with the x. So this is a horizontal stretch or compression. However, just like with our horizontal translations, this lies to us. So rather than stretching the graph 4 times, this actually compresses the graph down. It does the opposite of what you might think. So it's a horizontal compression. And again, we want to note by a factor of whatever. It's by a factor of not 4 this time, but because we're doing sort of opposite, in this case, since we're multiplying, opposite is really more like the reciprocal. So I'm doing a horizontal compression by a factor of 1/4. This will be scrunched down sideways, horizontally, so that it's only a 1/4 as big as the original parent function. And then as soon as we start to throw negatives into the mix, these negative signs will will have the effect of reflecting our graph. And once again, it'll depend on whether the negative is inside or outside of your parentheses or absolute value bars or radical or what have you. Anything else would still affect the graph in the same way. So for example, that 1/2 that's being multiplied in front, this will be a vertical compression this time. So I'll just make a note of that. A vertical compression, the vertical things always do what they say they're supposed to do. So a vertical compression by a factor of 1/2. It'll be half as tall as the original. That negative sign being outside of the parentheses or bars or whatever will have the effect of flipping your parabola. And you may recall what these parabolas look like if you graphed these before. My parent function parabola might look something like this, but a negative sign out front would flip the parabola upside down. So a negative sign out front, we're going to make a note of, it's a reflection, but then specifically, a negative sign out front like that will be a reflection over, or sometimes we say a reflection about, the x-axis. It flips it so it's upside down, so to speak. So it's a reflection about the x-axis. Okay? You can probably guess then what's going to happen if the negative is located inside the parentheses or inside the square root in this case. Again, it's going to tell you that we do have a reflection, but this time, rather than reflecting the graph upside down, it sort of reflects it sideways. And so if you imagine the parent function of your square root graph, looks something like this, a negative sign underneath the radical will reflect over the y-axis and give you a graph that looks like that. So we'll say that that negative sign inside is a reflection about the y-axis, the vertical axis. And then once again, we can make a note about what that 4 does. That 4 multiplier in front will be a horizontal. I think we just looked at one just like this, didn't we? A horizontal, and then since it does the opposite of what you would think, those horizontal compressions and translations always do the opposite. A horizontal compression by a factor of 1/4. We'll look at the reciprocal for the horizontal ones.